Hi everyone. Today we're going to study cross or vector product. The vector product or cross product of two vectors A and B denoted by vector A times vector B and is defined as vector A times vector B equals the quantity length of A times length of B times the sine theta. This theta is the angle between the two vectors, and this quantity is multiplied by a component n, where this component n is the unit vector perpendicular to both A and B. This illustration will help us understand our cross product. This is the vector A and this is the vector B. This is the theta, the angle between the two vectors. Now, this A times B, this is what we call the resultant vector. And we say that the resultant vector, that is vector A times vector B, is perpendicular to both vector A and vector B. Now, let us calculate vector A times vector B using determinants. If vector A equals a sub 1 I plus a sub 2 j plus a sub 3 k, and vector B equals b sub 1 I plus b sub 2 j plus b sub 3 k, then vector A times vector B, we will get a 3 by 3 matrix. The first row here are the elements for the components I, j, and k respectively. The middle row, these are the coefficients of vector A. So we have this a sub 1, a sub 2, a sub 3. The last row are the coefficients for vector B. So we have b sub 1, b sub 2, b sub 3. Now using determinants, we will have like this. This is element I multiplied by the square matrix a sub 2, a sub 3, b sub 2, b sub 3. Then minus the element j multiplied by the square matrix a sub 1, a sub 3, b sub 1, b sub 3. Then plus the element k multiplied by the square matrix a sub 1, a sub 2, b sub 1, b sub 2. Then we will just take the determinants for each of the square matrix, and it becomes like this. It means the I multiplied by this a sub 2 times b sub 3 minus a sub 3 times b sub 2. Then we copy the minus sign, we go to the next element j. That is now a sub 1 times b sub 3 minus a sub 3 times b sub 1. Then plus, we go to element k. A sub 1 times b sub 2 minus a sub 2 times b sub 1. Example 1. Find vector A times vector B if vector A equals I plus 2j plus k and vector B equals 3i minus 4j plus k. So we write here vector A times vector B, and let us write also the 3 by 3 matrix, and it is here. So in the first row we write I, j, k. The second row for the coefficients of vector A, 1, 2, 1 respectively. The last row is for the coefficients of vector B. So we write 3, -4, and 1 respectively. Now let us write I multiplied by the square matrix 2, 1, -4, 1. Then minus for the j multiplied by the square matrix 1, 1, 3, 1. Then plus the element k multiplied by the square matrix 1, 2, 3, and negative 4. Then let us evaluate the respective determinants. So we have this 2 times 1 is 2 minus negative 4 times 1 is negative 4. Then we copy the element I. Minus 1 times 1 is 1 minus 3 times 1 is 3. Then we copy the element j. Plus 1 times negative 4 is negative 4 minus 3 times 2 is 6. This is multiplied by the element k. Simplifying further, this 2 minus a negative 4, it becomes positive 6. Then we copy the I. 1 minus 3 will be negative 2. And because there is negative here, it becomes positive 2. Then we copy the j. Negative 4 minus 6 becomes negative 10. Then we attach the element k. This is now the final answer. Example 2. Find a vector perpendicular to vector A equals I plus 2j plus k, and vector B equals negative I plus j minus k. We note that vector A times vector B is perpendicular to both vector A and vector B. So this problem is similar to finding the vector product of these two vectors. So we write here vector A times vector B equals the 3 by 3 matrix. The first row is for the elements I, j, k respectively. The middle row are the coefficients of vector A, that is 1, 2, 1 respectively. The last row are the coefficients of vector B. So we write here negative 1, 1, negative 1. Using our idea of determinants, we write now the element I multiplied by the matrix 2, 1, 1, negative 1. Then minus element j multiplied by the square matrix 1, 1, negative 1, negative 1. Plus element k multiplied by the square matrix 1, 2, negative 1, positive 1. Let us now evaluate the corresponding determinants. So for the I, we have 2 times negative 1, negative 2, minus 1 times 1 is 1. Then minus element j. And then this is 1 times negative 1, negative 1, minus negative 1 times 1 is negative 1. Then plus the element k. Then we have this 1 times 1 is 1 minus negative 1 times 2, negative 2. Simplifying further, we have this negative 2 minus 1, so we write negative 3i. Then minus this negative 1 minus negative 1. This is simplified into negative 1 plus 1, and that would be 0. The 0 multiplied by j, this element j will be cancelled out. Then plus this 1 minus the negative 2. So it becomes 1 plus 2. We have positive 3 multiplied by element k. This is now the final answer. I hope you learned something from this video. See you again next time.